I'll go ahead and get started. I've got a lot that I'm going to go through. I'm going to go through it pretty quickly, and I apologize in advance on that. But I will try and, feel free to ask questions as we go as well. So first of all, thank you to our sponsors. Much appreciated for us to be able to be here because of them. Quick background on me and AI. I've been doing a lot of things with AI, from machine learning to building agents to collecting data. That's one of the things I work for a company called Lifter Insights that does data collection on AI. So we're learning a lot along the way. You don't have to read all that. I'm just showing you. Here's what I asked AI to do. Actually, I had it, generate a prompt for me, and then I did that prompt, and this is what it came up as. And so using AI in this case worked really well. You'll see where it starts to diverge later in the presentation. AI that you already know. Again, I don't expect you to read all those pieces, but the point of this is giving you a broader understanding of what AI is, what it can be, and kind of looking under the hood, as I mentioned, and giving you some reference points about it. And then the key message I want you to walk away with is question what you're getting back and think critically about what you're getting back from AI based on what you've learned. You will see that AI suggested that demystify AI, and I think that's bunk, because it's a very complicated thing, and I don't think it's easily demystified. And we'll get into that a little. So this quote, interesting. You've probably seen things like that. Basically, if you understand it, then you don't understand it, or if you think that you do. When you look in Perplexity AI, and I said, where does this quote come from? Perplexity said it comes from Melanie Mitchell. When I actually did the research on it, you can see that it's actually Michael Gonzaga, or Gonzaga. And I'm going to talk about that a little later, so remember that. But we've all heard of hallucinations. This is an example of a hallucination. But there's a reason why it makes this type of hallucination. And it's actually, when you understand a lot about AI, it makes a little more sense, as opposed to it just kind of pulling something out of randomness. So again, this is what AI suggested that I have for my slide on the left-hand side. You don't have to worry about it. You feel free to read that, but I just wanted to, I got into that, and I'm like, that's too much of what we're trying to do. The key point that I want you to walk away with, if nothing else from this, is that AI is about probabilities. And it's a matrix of probabilities. That's what's driving it. That's what, when we open up the hood and look at what's happening in there, it's about probability and statistics, essentially. The other point is that humans are probability. We are a matrix of probabilities. That's how we work, which is why AI works, and why a lot of times it's uncanny how well it works. It works very similar to how we work as humans. So I want to do a quick, this is not a good sample set, but I'm just going to do this real quick. Don't say anything, but I want you all to think of a number between 1 and 100 that's the most random number you can think of that probably someone else isn't going to think of. So what's the most random number you can think of between 100 or between 0 and 100, okay? Everyone got a number in your head? Put that in your head. How many people had either 37 or 73 as that number? Okay. So why do you think that is?
Because they're in between. They're like 3 and a 7, or?
It is, but our minds go through this process of, well, I'm not going to choose an even number. Even numbers not too. I'm not going to choose a 1 or a 9 because those are on the extremes. I'm not going to choose a 5, so I'm going to choose a 3 or a 7 because that's most unlikely, and then you're going to put those together. So
But that's so transparent, because I just thought that was the number.
Yeah, exactly.
Without any of that thought process.
Exactly, and it's our brains are doing this processing, and it's a probability matrix. And look up on YouTube. There's a good video, my Verison, talking about the number 37 and how humans, they did studies, and 37 and 73 come up statistically very often. So we're not as good at random as we think we are. So taking, has anyone here heard of Darren Brown? I highly recommend it. Very entertaining. He's an entertainer out of Britain, and the things that he gets people to do and to think about and whatever else, it's just all playing with the probabilities and what we're likely to say, how we respond, and we're more machine-like than we think we are. So I do encourage that. The number was the game I just did with you. So going back to the quote about Melanie, if you look at really what AI is doing, is it's saying, well, okay, Melanie's a person. She wrote a book about AI. In that book was a quote, and that's true. She wrote a book, and she quoted this other person, and assumed that because this quote was in her book, that it was because of her. It's piecing together all these pieces, and that's a mistake that humans are likely to make as well. Oh yeah, I think the quote was this person, even though it was actually someone else who was quoted in the book by her. So again, it's playing with piecing these things together. So it's a simple mistake, both for AI and for a human. You guys have probably seen these. This is probably not new, but when you talk about Google doing a Google search versus doing an AI search, it's 10 times in the amount of environmental impact because there's a lot more happening to get to that answer. Something to keep in mind when you're actually running a Gemini search is that it's using a lot more processing power than to just do a simple Google search. Also, just to have those images that I had for AI to generate, and this one's coming out, but it takes, the estimate is about the same amount of power that it takes to charge a cell phone. So there's a lot happening behind the scenes. So what's happening there? So I told you, we are probability machines. AI is getting into probability, and probability is essentially proximity. So let's pretend that this is a value that we're providing, what AI would call a token. So anyone know what a token is? Anyone? I mean, you've heard of tokens, but does anyone have a good definition?
It's a character. A character number.
Actually, it's not. It could be, but it's often it is just a word, or it's a piece of a word, or a part of a word. It's a concept, like a cat could be a token. And then AI has when you hear about these models will map cat with all these attributes. What are the attributes of a cat? It's got fur, it's in a house, it's got 4 legs, it's got a tail, it comes up with all these different pieces of that token. And so when you're entering and typing something in, AI is taking your word, translating it into a token for that, and then it now has all these attributes associated with it. And it's, so if we have a cat, so simple test here, but if I say cat, what's the first word that probably comes to all of your minds? Right. Most people are probably going to say dog. It's probably, it's right there. It's in your brain, it's got proximity to the concept of cat. But if I started naming other things with tails, you'd start thinking, okay, well, the tails, or you'd start to expand on that. But what AI is doing is saying it's taking that token and it's going to compare it against several things. This is just on a linear, and let's say on one attribute. So they're both things with tails, for instance. I'm going to expand on this. This was just funny more than anything else. I asked AI to generate me a simple XY axis grid with these points, and for some reason it just wasn't understanding what an XY grid is. But I was laughing about it, so I was like, I'm still going to put it in there. But just pretend that this is an XY grid with the different points. So when we add another dimension to this, now, this one is easy of which one is closest to this. Well, this one is closest to that. Now here, I'm now comparing on 2 axes. So in this case, this one's probably just a tad closer. This could be, I'm saying, something with a tail and something with 4 legs. So I'm comparing something based on a couple different attributes. So I'm again looking for proximity based on certain attributes. Take that out another dimension, 3 dimensions. So now I'm comparing more things, and I'm doing these comparisons by proximity. And that goes on, and in the AI space, we only think in 3 dimensions, but AI can extend out, 20, 30, 50, 100 with all these different attributes that something has. And the more attributes you have that you're comparing, the better you can, in theory, you can make this comparison. So each one of these, and this is happening for every single token that's in there. So if you have a 4-word token, it's going to do this. It's going to have a box of these for each of those words, comparing that to the model. So the dot would be that token that you have, and the other dots would be all the tokens that it has relative to the size of the model that it's using. So this is as complicated as we're really going to get, but I'm going to spend a couple minutes on this. I do want to talk about this real quick because, again, I just thought this was funny. I asked AI to come up with an image of a 3-dimensional graph and gave it some prompts. And this is what it came back with, which looks like it might be something, and you're probably like, Toontal Thai, boy, what is that? But all that it was doing is saying, well, if I've got a graph, I typically have a thing up here that looks like letters, and what are the most likely letters that it look like, and it was just putting, so it's again giving you an example really of, yes, it looks like it's hallucinating, but there's actually logic behind that because it's saying what's that most likely to look like. It's not thinking in terms of letters, it's thinking in terms of shapes and colors because I asked it to do a chart on that. So it knows from what it looked at, that pool of different charts and graphs that it looked at, they tend to have something up in the right-hand corner and tend to have a certain number of letter-looking things, and they tend to be these shapes. So it's put that together. Anyways, going back from here, so think of each one of those cubes. And now each one of those cubes is here. And we're going to just take one row of this. And I promise this won't get too much more complicated. But just that one cube is this one. And then we can take that top section of that, and that might be your whole sentence that you provided to the AI. When you ask a question, it provides that entire sentence and puts it together. And what it's going to do now is it's not just going to take that sentence and evaluate each token. It's going to take that sentence and evaluate each token and the order of the tokens and the tokens compared to other tokens. So if I said the dog ate my homework, it's going to, I can't just take dog ate homework because if those words on its own, did the homework eat the dog? I understand the order of them in the way that they were presented, and I need to evaluate them together. So AI is doing that comparison among each of those tokens together, and then it starts to take that and cross-reference all of those, which is where you start getting into these different layers. And it's also taking that compared to its, keep in mind, every one of these is its package of probabilities based on the model itself. So it has all this data that's comparing, cross-comparing, looking at, referencing, looking at the order. And on top of all that, it's taking, if you've asked previous questions, prior to that, it's what's called context. So if I start a conversation and say, I need to create a report for my business, and then I say, can you make this report a 5-page report? It knows that you're talking about the report you just did because it has context. So every question that goes into AI is now taking all the context from before and layering that in, which makes it all the more complicated. And it's taking this cube and doing it all these different ways. It's cutting it horizontal, down, each of those, if you kind of poked holes in it, it's evaluating each way. So every question quickly expands out into lots of pieces, and all of this is comparing probability. So there won't be a test on this, but the point here is that we have taken some simple tokens, and even if it was 5 or 6 tokens going in, and we've expanded on that to do this evaluation compared to a model that has been built to come back with what our probability is. So I just threw a lot on, and you don't necessarily need to know all these words, but you will hear tensor often. A tensor is essentially one of these layers of all these cubes within that. It's just a collection of all the variables that are going into the question that you've asked. It's taking your question, translating it into numbers, and everything in here is just a series of numbers that it's comparing and looking for probabilities based on proximity. So that was a lot. What questions so far? So let's talk about how some of this comes into play. So you've all seen AI generating when you're doing emails. That's essentially AI that's running. It's factoring in several things. If I'm doing my email, it knows, first of all, it knows who I am. And second of all, it knows some basic concepts about email. It knows that if I am writing an email to someone, that someone is in the to address up above. Okay? And it knows it's been trained on how emails work and how human communication works. It's looked at a lot of them. So probably the most likely first word, if I start to write, is going to be hi, or hello, or hey, or something like that. And it's going to learn that, oh, Drew tends to say hi before the name, or Drew, so it's going to learn from me as well to do that. So it's basically saying, probably this is the first word you're going to say. And then probably the next word that tends to follow hi is the name of the person that it's addressed to, and I can see that up above. So it's, again, using probability to determine what's next. So, hi, Nancy. Hi, Nancy. What's the next most likely word? It's probably going to be I, you, or she, or something like that. So, and I can look back and see you tend to start your emails with I, so I can, if I'm more fine-tuned to your use of AI, I'm going to be a little better at this. So well, what would come after I? Well, I would like. So you get the point here is that it's going to be able to piece through each of these, figuring out the overall context of where this AI is being done and what is the next word in it. And it is processing on a word-by-word basis, which is why when you use ChatGPT, you see it spelling out and whatnot. When it starts, it doesn't know where it's going to end. It's working through that piece by piece. You are literally seeing it process the output of it processing as it is processing. And it's just a generation of what's the most likely next thing to happen in this, all based on probabilities. Questions? That's about as deep as we're going to get, but yes?
I think I noticed sometimes it goes back, like, for example, like if I use voice transcribe, like on the recorder app at Google Pixel, like, why does it go back sometimes? And like, how does that work?
Yes. So I don't know all the answers to that, but I do know, well, there's two things here. One is that you will start to see on some of these where it's telling you what it's doing, right? There is that where it's saying, I'm going and reasoning right now. And then it might start and tell you, hey, I just reasoned this and this and this, and then that disappears, and then it says, now I'm doing this other part. And now I'm going to go and I'm going to go generate the image, and I'm generating an image with this type of information. You're starting to see that more often where it's kind of talking out loud. But what you're talking about is a slightly different thing where it starts to give you the answer, and you start reading the answer, and all of a sudden it's like, whoop, and it goes back. I think what's happening there is it's getting into a point where it's done the calculations and it's like, okay, this doesn't make sense for me to continue down this road. So let me take that other option that I could have taken earlier on and path off that other option. Because if you go back to, or even right there, this slide right here, it's never easy of exactly which one. It's not like there's an obvious next choice. There's a variance there. And in AI, you'll hear about temperature of, how fluid do you want this to be? You can tell AI to allow for a wider breadth of possibilities, or you can say, I want the most precise answer you can give me, which is going to be, give me exactly the next thing in there. So it could have a possibility of, here's possible paths I could go down. I'm going to explore down this one and try and give the answer here. But at some point, it's like, okay, this isn't really working out, and it's not fitting into the algorithm that I had. I'm going to start down the other. So I don't know exactly what it is, but that's my speculation as to what's happening. Yes?
So what's it doing whenever it asks you, like it gives you two different prompts and has you pick between one?
Very similar to what he was just saying in the sense that it's saying, if I go down this path, I get you this answer. If I go down this path, I'll give you this answer. Part of that is driven by the provider. So Google, for instance, might say, we want to test out using a different temperature and see if people tend to prefer what's called warmer temperature or a colder temperature. And so they might give you two paths. One's the colder temperature version, one's a hotter temperature version. or there's lots of layers that they can adjust and levers that they can pull. So they might deliberately pull some, or they might even tell AI, try out some different things and let AI figure what levers to allow you to use. And it's giving you options, but it's learning from you of, okay, people tend to prefer the warmer answer, or people prefer to answer the longer answer. Okay?
And is this just for Google AI that you're talking?
This is true for any type of AI.
Hello.
What happened there?
There's a light
Yeah, AI didn't like the answer. It's like, wait, wait a minute. So yeah, this is true. The concepts are true. AI is a wide variety, and actually that gets to the next thing we're going to do when it comes back up here. It should come back up for a second after it flashes a little bit more. So just extending on that real quick, this whole concept of probability is where these hallucinations come from. So for instance, this is a valid website on our website. We talk about cloud, but we also talk about AI. So it would be reasonable to assume that there might be an AI dot whatever. And it's again working off of probability to get there, and that ends up as a hallucination, which is where you're like, how could it even come up with some random website that doesn't exist? Well, it's not looking at websites. It's just looking at this as a really long piecing together of letters and words and essentially tokens. So hallucinations are just piecing together probabilities, and you can do in AI what's called guardrails, which are things that after the fact can evaluate the answer and make sure that it doesn't go wild in giving an answer. That is very difficult, though. So I want to go through some, let's see, how much time do we have? Probably not much.
Actually, that's it.
It's okay. Yeah, let me just do one quick thing here, which is just talking about chips. If anyone's seen this, so this is a traditional AI or chip, not just necessarily AI. Have any of you seen the Princeton chip? It was AI generated, and so talking, AI going off in different directions. This right here is the Princeton chip, and it was AI processing, and they were told to create. It was told to create another chip, and it looks so different from what we have, but it works. And the scary thing about this is they don't know why it works, but it works. So yeah, that's the Princeton chip, and I'm going to jump ahead here. So future of AI, AI is powerful and going to get even more powerful because now you can start having those chips designing other things that are just outside our capacity to understand. And dangerous is the key question here. But from our standpoint, the key things I would say is don't be lazy about AI. We tend to be lazy. You need to be critical. You need to be thinking, you can't just take the answer that AI gives you. Like right now, Google and these, they want to say, here's the answer. You ask a question, here's the answer. And a lot of times you can ask AI, is that really the right answer? Or I don't think that's the right answer. And it's surprising the number of times it'll say, you're right. That's actually, I was wrong. And because it's not a sentient thing. It's just going through, this is probably the answer, is how you should read the responses that you get. So be very critical about that. And then that's, again, thanks to our sponsors. So. Any other questions?
So I love when you said at the end, right, be critical with AI.
Yes.
However, if we are not trained to be critical thinkers, then how do we ramp up?
Well, it's really just being a critical thinker is just saying, is this really, well, first of all, assume that that's not the right answer. It's only got a certain probability of being the correct answer. Right? So you can't take anything with certainty, especially these days when there's a lot of bad information out there. So just starting out with saying, This may not be the answer. It's an answer. It's a good starting point, but you should still do more research. That's, if nothing else, that's how you can look at things critically.
Well, because the database that from which it queries the question, there's a lot of misinformation and there's a lot of bias, there's all kinds of stuff.
There is. Yes, there is. But even we've done it with databases that we've provided where we're just like, this is all that you need to think about. This is all that you need to do. And it still comes back with wrong answers. So you would think that it's, well, if I give it all the right information, it should give me the right answer. And that's not even the case. It's still working on probabilities and what's most likely to be based on the general nature of how I've collected the rest of this information.
Also, can get confused if you don't. I sometimes break the pieces up that instead of saying everything I want, I need you to start here.
And it can work both ways. So yes, absolutely, is that how you ask the question can change what it is. But the other part of it is sometimes it's better to ask the full question rather than pieces. And sometimes it's better to ask them in pieces than the full question. But the thing with AI is you can do both and test it out. But you shouldn't take anything you get back and just take it as that's it.
What are some of the ways to avoid hallucinations?
I'm sorry. Oh, the guardrails? So for instance, one of the guardrails in an app might be if this information isn't from if you don't have a source that you can reference that exists, don't include the data. In other words, if you've made up the URL, don't include that. You can do things of if it's too, well, just even setting that temperature I was talking about of how far out of probability do you want to accept, you can narrow that in. You can have, we were actually talking earlier that I think we'll see this in the future of AIs that will evaluate an answer before it goes out to someone else, before it gets sent, that AI's only responsibility is to say, is this a reasonable answer for the question that was actually asked, and maybe ask some other questions of the AI before that answer is delivered to the user. So there's a lot of ways to do it. It's a really hard thing to manage, to create guardrails because there's so many possibilities right now. Yeah.
I'm curious what the Princeton people prompted to get the
Yeah, I don't know. I don't even know how you get to the point of it even printing it and whatnot. I can imagine it's a very long, complicated prompt to do that.
Skynet.
I don't know if they talk about it working better, but for what they asked it to do, it worked. And again, the scary part is that they don't know why it worked because it's not a direction that a person might have gone down that road, but we work off of iterations of things, and this just went off in a different direction. Just said to solve this problem. No, and that's the scary thing about AI is it can't tell you why it does what it does half the time. There's a lot right now on trying to break down the systems and processes for it to tell. Yeah.
But maybe we're not smart enough.
Oh, I think we are at the point where it's going to, with AI, training AI. DeepSeek was a game changer in the concept of AI training AI, and that's the first stage. We will get to a point where we don't understand how things work. And one of the misconceptions I had up there is that there's people that understand AI fully. I don't think anyone understands. I mean, the whole Princeton ship, they're like, we're not quite sure how this works. I mean, people don't understand how it works, and we're only at like stage one of where AI is going.
So one of the complaints is that it doesn't cite sources, and there is an allegation that it does it specifically so that be able to alert that it has a copyright violation. Can you comment on that?
No, that's well, it can in some cases. The problem is the way that these are built is it's just taking all these things. It's not specifically looking at when it was built. It's not looking at URLs. It's just looking at content. So it doesn't know where the content came from any more than if I asked you, hey, what's your, something that you like. That may have been influenced from many different things. You probably couldn't go back and say, well, I like chocolate because when I was a 2-year-old, I ate whatever. You're not going to know all the pieces that went into that. It doesn't know most cases. If you do things like RAG pipelines and whatnot, you can set it up to site sources, but you have to design around that.
So is it specifically designed not to cite sources, or like why does it not cite sources? Because like when you buy something from a specific place, right? You don't just have like, for example, like a phone, right? I have a phone, and I don't just like forget like where I bought it from, right? I remember where I bought it from.
Well, but if I asked you, who's the first president of the United States? You'd say, okay, George Washington. Let's say we agree on that. What's your source for that?
Well, there's multiple sources for that.
Right, but yes, but where's the source? Where's the first source that you have on that?
That's a very generic question, but like very often the question
But that's-
that they provide an answer for, it's found in a specific source, right? So how come it doesn't know which source it found in?
It has it in it. It's the probabilities of where it is. It's not going to look to that website. It already has that information. Most of these models you can run disconnected from the internet, and they'll go that. They're not actually looking to those sources at that point. They're looking at what they already have.
Right. But how come they don't know like where they got that information from? I mean, like if I have a specific information, like
Because it's not how they're built. They're built on these structures and whatnot. It's not part of how they were originally designed to link back to these sources. So, I think I just want to make sure I'm not interrupting into someone else's time. You guys aren't presenting.
I'm supposed to start in 5 minutes.
Are you starting? Is it you or is it?
It's me.
Okay, then go ahead. Okay.
Okay, so say, just a Princeton chip, for example, it has to pull information from somewhere. How does it know what order to pull information from? Like, is it go by Google hits or, what?
So I can't speak specifically on the Princeton chip. I'm sure it wasn't just one prompt that they said, create a chip that does X, Y, and Z. I think there were several things that went into that.
Which is, how does it know, whether to take the top of the list of results or the bottom, or, how does it?
It goes back to the whole proximity. I mean, of all the pieces, all the tokens, that it's done that proximity to figure out what the likelihood and probabilities, and it's putting those together in this more complex matrix to say, here is, of this whole answer, or of this whole question, here's the most likely answer to that.
So maybe like even if it might be a false state, I might pull it and use it anyway?
Yes, it doesn't know truth versus false. It just says, here's what I have associated this to this.
And maybe like the George Washington example, like the founder or whoever made just put that information in, right? It didn't say, find this and.
Well, it probably saw it in multiple sources, for one thing. Right? Some are wrong, some are whatever else. And it's just saying, if someone says first president and United States, the closest thing in proximity is George Washington. Why it knows why that proximity was set there, it doesn't know.
You're helping me, like, it could totally link to something else that those videos that they make the heads on people, on state bodies.
Yep. Yes.
Relate to something that has nothing to do with actually just his head.
Yes. Yeah. And it probably somewhere close to that is Washington, D.C., which has nothing to do with necessarily that. I mean, there's all these things that are in this universe of probabilities and possibilities associated to it. I'm happy to talk more later on, but I also want to make sure we clear out the room. So thank you very much. Thanks to our sponsors.